Next up, we have effective Go. Now, this is a document that is written and maintained by the Go team, the people who have built the language. And this document is all about all the conventions, idioms, and standards that one should follow while writing Go code. And the reason it is written is because a lot of people from a lot of different ecosystems and language come to Go. They adopt Go after some time because Go is relatively a new language and it came around in the year 2009, right? And before that, we already had a lot of languages. We had Java, JavaScript, and C, C++, a lot of languages, a lot of system languages, a lot of high-level dynamic language, etc., etc. And the team wrote this documentation, this piece of article, because people who were coming from other languages and other ecosystems, they were trying to enforce standards and conventions of those ecosystems and those languages while they were writing Go code. And of course, that resulted in a lot of bad code and eventually a lot of bad performance because of the bad writing style of the code. And that is the reason the team wrote this document, so that if you are new to the language, or even if you are intermediate Go programmer and you've been writing the language for a while, this document will help you consolidate all the conventions and all the right mindsets that one should have while writing Go code. This basically teaches you to write Go programs the way they were supposed to be written. That's why we are going through this document. This is one of the most important document. This is one of the most important resource that you should follow while you are on your journey to learn the language. Because you can learn how to write Go code from a lot of other tutorials and a lot of other resources, right? You can get started with the language instantly, but you'll only learn how to write good idiomatic code through this document. Of course, you can read it yourself and move on without watching this video. And in fact, I would suggest you either read the document first and watch the video, or watch the video and read the documentation, so that you have a comprehensive understanding in case I missed something. Of course, it's not possible to go line by line and cover every single point that this document makes. So it's definitely recommended that you either read it yourself and then watch the video, or watch the video and then read it later. Okay. Now let's start. This is just an introduction of how what is the philosophy that you should have while starting with the Go language. It just says Go borrows a lot of idea from a lot of existing languages, but the conventions, the standards, the style of writing Go code is unique as compared to other languages. So if you're coming from other languages like C++ and Java, then read this document and understand how you're supposed to write Go programs. Don't try to enforce standards and conventions from other languages and other ecosystems inside Go programs. Right? That's all this mentions. And there is a note here which says that this documentation is relatively old. It was written during the release of Go version 1 in 2009, and it has not been significantly updated ever since. Okay, it documents some of the conventions and standards which are pretty generic. Those rules and those guidelines are still applicable to this date. We are in 2025 right now, and they are still applicable. And I read this document at least every few months to revisit the original ideas. So it is definitely not outdated, but it is definitely old when it comes to all the new features and all the new modules and etc. A lot of features that were added to Go over the time. All of them are not documented here. Just some generic guidelines and standards are recorded here. So you should not take this document as a comprehensive resource. Okay, there are other resources. For example, we have already explored language specification, the tour of Go, and soon we'll also explore this resource, how to write Go code. Right? All these resources together make your learning resource more comprehensive. But this document itself is not very comprehensive, and it is relatively old. Okay, and with that, let's start. The first thing is, the first philosophy of Go is the formatting, the style of your Go program. And it basically says that programmers, developers from other ecosystems, other programming languages spend a significant amount of time deciding and debating over what style to choose for their team, for their organization, and for their company, right? For example, for JavaScript ecosystem, we have Prettier. For Python ecosystem, we have different formatters like Black formatter, and we have Rough, etc., etc., right? There are a lot of open source formatters and a lot of styles and guidelines and style guides that come into play in other ecosystems because of the diversity of different teams and different companies, right? And initially, when Go was originating, the team decided that this should not happen. People, programmers and developers should not spend a lot of time deciding and debating over the formatting, the style of the program. And that's the reason Go comes with a program called gofmt. It is a CLI program, but if you use an IDE such as VS Code or NeoVim or Golang, does not matter. The gofmt program is a CLI program, also comes in terms of IDE integration. In VS Code, it's an extension. When you install the Go programming language extension, you also get the gofmt program inside your IDE. In the same way for other IDEs. So inside your IDE, you can run formatting for your program, and your IDE will use the gofmt program to format your Go code, right? So the formatter is inbuilt in the language, and that's the whole idea. And not just the formatter, but the style. There is not a lot of customization available in the gofmt, and that's the reason when you open a Go program, let's say we go back to, we have around 5 open source repositories. These are very famous ones: Fider, Focal Board, Harness, Incubator, Answer, etc., etc., right? And on a high level, does not matter which code base or which part of the code base that you are opening. If you take a look at it on a very high level, let's say we are in this code base, and when you take a look at it, now we open another one, does not matter which one. The first thing you notice is pretty much all the programs in all the code bases and all the parts of code bases pretty much look the same because of the standard formatting guidelines, right? The gofmt program formats your Go code. And since it does not have a lot of customization capability, people writing Go programs all over the world, all their programs look similar. And the advantage of this is developers don't have to exert a lot of mental overhead deciding or making sense of a program, because admit it or not, if you have been working in a particular code base which follows a particular standard, let's say it has different standards for double quotes, single quotes, different standards for conventions like indentation, etc., etc., and suddenly when you switch over to a different project and that follows a completely different set of styling guidelines, now there is some amount of mental overhead that goes into it to make sense of the program, because humans perceive visual patterns everywhere. So even when you're reading normal text, the styling of the text, the indentation, the paragraphs, the token semantics, etc., etc., all of these things take some amount of toll to figure out and make sense of. And this is a huge advantage when you're writing Go program. Does not matter which code base you are in, which company you are in, which part of the code base you are in, everything will look similar because of the standard generic styling of the gofmt program, right? So if you want to take a look at it, let's say we change the formatting, right? We just get, and then when I run the formatting again, everything goes back, right? So these kinds of things, the formatting that a IDE offers, that a language ecosystem offers. This is, the styles are pre-decided when it comes to the Go ecosystem. You don't have to come up with your own styles. Okay, that's all it mentions in the formatting section. Now moving on, comments, we have already explored different types of comments that Go has. One is block level comments, that is used when you have a paragraph of content that you want to put inside a comment. And then we have line level comments that is written with double slash, and that line will be commented out. We have already explored this in the previous Go basics video, right? In names, that we already know the visibility of a variable of a type or any kind of identifier outside of a package depends on whether the first letter of that identifier is uppercase or not. That's how Go ecosystem works, right? And there are some styling guidelines when it comes to how to name things. Okay, because in the whole world of programming, right, the hardest thing that you can come up with is how to name things. And it sounds a little exaggerated, but when you're writing huge programs, when you're writing huge libraries, at some point you will encounter this problem that your names are clashing, or you are having a very hard time coming up with new, meaningful and short names, right? Okay. Now the first thing to note here is your package names should be small case, without any underscores or spaces or etc. They should be small case and as short as possible. Of course, don't go abbreviating them like BS or YT, etc. But they should be meaningful and short and small case. That's the guideline you should follow. Then the second thing is, this is the important thing. When you're naming things inside a package, let's say you're naming some variable, right? Or you are naming some type, or you are naming some function, etc. Always keep in mind how the consumer, how the other part of the program that will be using your variables or types or functions, etc., how they'll be using it. This is how they use it. The first part is your package name, then followed by a dot, the name of the variable or the name of the function or the name of the type, right? And the reason for mentioning this is, when you're naming things inside your package, don't try to pollute that with parts of your package names. Let's say we have a package called books. We have package books, and inside this we are declaring a variable type, and it is of type string. Now the point here is, when you're naming things inside a package, don't pollute the name of the identifier with the package information. Which means when you're naming a variable here, don't name it as book type, because the other package which will be using your books package will anyway import it like this, right? Will anyway use it like this, books dot type. And as you can see, this is a little redundant, right? We already have a scope or a namespace by which we are referring the variables, the identifiers, the functions, types, whatever, and polluting it with the package name just adds redundant information to the whole execution line. So ideally, this is how the call, the X call should look like, books.type. And when we do this, this does not lose any information when it comes to meaningfulness, and it's not confusing, and it also does not have any redundant information, because this clearly states that we are trying to access the variable type from the package books. So most likely it's a type of book, right? And this is how you should think about naming things when you are inside a package, when you are naming identifiers inside a package. Then we have getters and setters, how you should name them. So in other programming languages, other ecosystems, the object-oriented or class-based ecosystems, there we have the concept of getters and setters, which basically means you have a class and you create an instance of that class, which we call as an object. And inside that we have getters and setters so that we can use them to get the value of a private variable and set the value of a private variable without exposing the variable itself to the other parts of the program. That's why you use getters and setters. So the naming convention when it comes to getters and setters is, if you have a variable called owner, is small case, is not accessible outside of the package, then the getter of that identifier, that variable, should be the variable with the first letter as capital, because we already have this capability that all the identifiers which have the first letter, an uppercase first letter, will be exposed outside of the package. Since we have that capability, we can use that to construct or to name our getters. So this clearly states that this function basically fetches, gets the value of the current instance of the owner, right? In the same way, you can name your setter with the name of the identifier with a prefix of set. Okay. And similarly, when it comes to interface names, the convention is you should suffix them with an ER. And the reason for this is interfaces, by their meaning, they express a certain set of behaviors, a certain set of actions that a particular type can perform, right? Let's say we have an interface called formatter. On a first look, you can say that whatever type implements this interface has some kind of function called format, right? Because this interface is a formatter, whatever type that implements this interface. Of course, in Go, you implement interfaces implicitly, right? Through your behavior, through your methods. Now, whatever type that implements this interfaces has some kind of method called format, etc., etc. Same for close notifier. On the first look, you can tell that there is some kind of function called notify, which implements this interface, which is called close notifier, right? Is an ER prefix. And because of this prefix, on a first look, you can tell that this is an interface. So when you are importing interfaces and when you are using them in other places, on a first look, you can tell whether this is a struct or this is an interface, judging by their suffix. If it has an ER prefix, you don't have to explicitly click on that interface and go to the source where it is defined, then find out that it is an interface. On a first look, if it has an ER suffix, then you can tell that this is an interface. So it saves some amount of time when you are navigating code bases, right? Now, finally, in Go programs, the convention when it comes to multiple words is used either mixed caps or this form of mixed caps or this form of mixed caps. When you are trying to expose an identifier outside of the package, then of course you will use this form because the first letter is uppercase. Otherwise, use this one. This is basically camel case, right? Either camel case, this form of camel case or this form of camel case. We don't have the convention of using underscores, right? Like we do in Python. In Go, we use camel case to write variable names which has multiple words. Okay. Now the next section talks about semicolons, and there is nothing new to understand here, which basically states that in Go programs, you will not see semicolons explicitly inside your programs, but when the compiler is compiling your program, depending on the semantic breakpoints, it puts semicolons in convenient places so that it can make sense of the program. So that's all there is to it. There is nothing to understand semicolons. Then we have control structures. When it comes to control statements, Go offers some of the constructs like if else, which we have in other languages. And when it comes to loops, Go only has one kind of loop, which is for loop. And depending on the kind of syntax that we are using, we can implement different types of loops. For example, we can do a while loop and a do while loop, etc., etc. Different styles of loops using the single construct, which is for. Same way we have switch and select for different use cases like multi-way communications, multiplexer, etc., etc. that we have already seen in the Go basics video. So in Go, a simple if looks like this. We have the keyword if, then we have a condition without any parentheses, etc., etc. Then we have a mandatory braces, right? This braces is mandatory, even if there is just one return statement inside this, but still we have to put this braces. The reason being, it is more readable as compared to doing the whole thing in a single line. Okay. In if statements also, we have another capability, which is we can declare a variable at the first part of the if condition, and that variable will have the scope, which is the if block and all the subsequent else if blocks. Another style to note here is when you are writing programs, usually if we have a success condition and we have a failure condition, so usually what we do, we do the thing, the operation which might result in an error or a successful response. We perform that operation first. Then first we check all the error conditions, right? When we are checking here, we check the error conditions. If the error is true, then we perform some additional error handling operations, or we just return the error, etc., etc. Then we move on to our happy path, whatever operations that we are supposed to execute when the program does not fail, right? We do not put this in an else block. Okay. And this is the convention. You handle all the errors in the first part of the program, and you just omit the else block and continue with your happy path, which is all the operations that you're supposed to do when the program does not fail. Okay. We should not use if else in all places, especially when we have a return condition. If we do not return it, let's say we have a variable, and if error is not nil, we assign something to the variable. Otherwise, we assign something else. If we have a scenario like that, then of course you can go with the if and else construct. Otherwise, if we have a return condition, or if the variable has some kind of initial state that you do not need to change, it does not fail, then you can omit the else block and continue with your happy path. So that is one of the standard that you have to keep in your mind. Then it talks about redeclaration and reassignment. When you are writing Go programs, often you will encounter this situation, right? You are doing some kind of operation, and that might result in some data and some error in the second position. And some lines down, you might encounter the same kind of situation again, right? You have a function call, some kind of operation, and it might return some data and some kind of error. And if you notice this, we already have a variable called ERR, and here we are using the short variable declaration form, which basically creates a new variable. It does not, if we had to only assign a new value to the variable, we use only the equal symbol. But when you use the short declaration form, the colon and equals, it creates a new variable. But this style is not wrong in Go. And in fact, this is encouraged, and the team has allowed this kind of things to happen so that you can have a single error variable which will keep getting reassigned every time you perform a new operation and you use this short declaration form. So at this point, this error has the error value that comes from this operation, but at this point we don't create a new error variable, but whatever error that is returned from this operation is reassigned to this variable, assuming the fact that both of these are returning a variable which is of type error, which is an predefined error interface provided by the Go runtime. Okay, that's what it talks about in the redeclaration reassignment section. Now moving on, we have for loops, and as I mentioned, we have different kinds of for loops, and depending on what style of the syntax that we are using, we can implement different constructs, like our traditional for loop, which has an initial statement, a condition, and a post execution statement, right? Same way, we have a while loop, we have the keyword for, we have a condition, and as long as this condition is true, we execute all the statements that is inside this loop. And the same way, if you just have one for, this is an infinite loop. This will keep executing all the statements in different iterations unless inside the statement something breaks out of the loop. It calls the keyword break or return. Okay. Now this is what the traditional for loop looks like. We have an initial statement, then we have a condition, and then we have a post execution statement. Same way we can use the for loop to range over things. Here we are ranging over a map, and with each iteration we'll have a key and the value for that iteration. Similarly, if we only need the key, then we can omit the second value, and for each iteration we'll have the key of that map. Okay. And the same way, if we don't want the key part, we only want the value, then we can omit this by using the underscore syntax, and then we can move on with just using the value. Then we have switch statement, and Go switch statement is pretty much similar to what we have in other languages. We have a keyword switch, then we have a evaluation parameter or some kind of initialization statement. Then with each case statement, we check whether this condition is true. If that is true, then execute all the statements that follows in that block. And similarly for other case statements. Now, it is pretty much similar to other programming languages, but it provides some other capabilities. For example, this case, where if you omit the initialize statement, the first parameter of switch case, then we can use this construct as an alternative to if else if chain, because this is more readable and it is more easy to make sense of. And similarly, we have this construct where, since Go does not provide the capability of automatic fall through in switch statements, so if you want to match multiple statements inside case, what you can do is you can separate them with a comma and write all your different statements in a single case statement. So in this case, if C matches any of those characters, then we will get inside this block and will return true. And that's all about switch. And we also have a type switch, which basically means if we have a variable which is of type interface, and we want to find what is the internal type of that interface. What is the type that resides inside that interface, which implements the interface. We can find it out by using this construct, which is called a type switch, which basically means you type the name of the variable, the interface variable, and you write dot, and inside parentheses you write type. And in each case statement, you can check whether the type of that interface variable matches boolean or integer or pointer to boolean or pointer to integer, etc., etc. If none of these match, then we get inside the default block and we execute this statement. That's what we use a type switch for. Now, moving on, we have functions, and this is what the typical signature of a function looks like. Even though this is a method. Now, one capability of Go is functions can return multiple values, and the reason this capability was provided because in earlier languages like C and C++, etc., if you want to indicate that this function has failed, you return something like a -1 or etc. to indicate that this function has failed. This function is returning an error. So the developer has to jump a lot of hoops to implement proper error handling for different function calls. And that is the reason the Go team, the team who created the Go programming language, they provide this capabilities of returning multiple values from a function, so that one can be a data point and another can be an error value. And depending on the existence of the error value, you can decide which flow to follow from that point of time. And similarly, Go provides a construct for named result parameters, which basically means at the start of the function, you can write names for the return values. Usually what we write int and error. We don't give names to the return values. But if you do it, then at this point of time, before anything executes in this function, n will be initialized with the 0 value of integer, which is 0, and error will be initialized with the 0 value of error, which is nil. And at the end of the program, when you just write return, you don't have to explicitly mention n and error. You can just write return, and the program implicitly will return both these variables. That's the use of named result parameters, even though I personally don't recommend following this pattern, because if you have a long function, it becomes very hard to keep track of when we are returning which variables, etc., etc. Right? It might cause bugs and might cause readability issues. So even though the capability is there, we should try to avoid it. Next up, we have defer. Defer we will ignore because there is nothing new here to understand. We already covered defer in a pretty extensive way in the previous video, the Go basics video. So we'll move on to the next topic, which is allocation. So overall, Go provides two different kinds of allocation methods. One is using new, and the second one is using make. Now what new does is, if you provide a type to new, let's say we have a type called book, which is a struct, and it has one field called name, which is of type string. Now if we have this type and you provide this type, so we want to initialize a new variable and we are using the short declaration form, and when you do this, you provide this type new, type book to new. Now what you get inside this variable B is, this book type is initialized with all the fields of 0 values. So since it is only one field called name, it will be initialized with the 0 value of string, which is an empty string. So B will now have a pointer to this type, a pointer to the book type, and the value will be inside the type. The field name will have the value an empty string. So this is how new works. It takes a type, it initializes to its 0 value. For struct, all the fields of the struct will be initialized with the 0 value. Same for slices. But if it was a primary type like integer or boolean or etc., etc., then integer it will be 0, for boolean it will be false, etc., etc. And it is initialized to its 0 value, and it will return a pointer to that value. Instead of returning the value, it will return the pointer to that value. That's how new works. And because of how new works, we can get rid of a lot of boilerplate, because we are already getting a 0 value state of a type and we are getting the pointer to it. So that does get rid of some of the boilerplate in some kind of programs. Now, for some situations, a 0 value state is not ideal. That's why we have constructors. This is what a typical constructor looks like for a type. So let's say we have a type called file. So the constructor of that type will be something like this, new file. Okay. And we provide all the arguments and all the parameters that goes inside to construct this type. And we can initialize it like this. And to make it a little shorter, we can also do it like this. We can take the name of the struct and we can pass all the values and we can return a pointer to it. Similarly, how make works is, first thing, make is only used for 3 kinds of data types, either slices or maps or channels, because these 3 types of data types are called reference types. And they are called reference types because internally they depend on a different data structure. For example, slice internally uses an array, a backing array, to function properly. Similarly, map has internally different types of buckets, hash maps, etc., etc. And same for channels. And since these are reference types, make is used to initialize them. And unlike new, make does not initialize them with a 0 value, because a 0 value of a slice is nil, or a map is nil, or a channel is nil, and we cannot really use them, right? So initializing a slice or a map or channel with new is pretty much useless, because they'll be initialized with the 0 state, which is nil, and we cannot really use them. That's why we have make to initialize these data structures, slices, maps, and channels. And using make, you can take a type. Let's say we are taking a slice of integers, and here we are defining the length, which is 10. And here we are defining the capacity, how much capacity the backing array, the data structure that is being used in the background, should have. That is the capacity. Now, make takes all these different data points and it returns you a slice of integer with a length of 10 and a capacity of 100. Now the next 3 sections talk about arrays, slices, and append. In the previous video, we have pretty much covered all there is to arrays, slices, and how append works, etc., in a very comprehensive way with examples and from references of different code bases and by looking at standard library code, etc. So there is no point in repeating the same things, so we can omit these 3. Maps also we have already covered, no point in going through that again. So moving on. Okay, print. I think this is something that we can talk about. So Go provides different types of print functionality, and some of those print functions are formatted printing, which follows a similar style which C follows, which means you can, before printing it to the console or different output streams, you can format your data in different ways. As you can see, we have different verbs, like we have %d, we also have %s, we have %d, etc. for different functionalities. For %d is usually used for decimals, integers basically. So in this, hello 23 will be printed in your console. Then we have fprint. Fprint basically takes an output stream. It can be your standard output, it can be some other file, it can be some other log output in your server, it can be anything, right? In the first parameter, it takes an output stream. Where should it print it? Whatever you are providing it to. That's why we use fprint. Then we have println, which basically takes any number of parameters, any number of arguments, and prints them and adds an empty line, so that whatever you print after that gets printed in the new line. Okay. That's what I use println for. In the similar way, if you are using sprint, it does not really print to any output stream. For example, your console or any other file, etc. It just returns it in a new string. That's why when you are using it, fmt.sprint, hello23, this part will be returned to fmt.println, and println will take that hello23 and print it in your console. Okay, that's how different print functionalities work, which are all imported from the fmt package. We have different verbs for formatted printing, but the default verb, which is %v, which is called a catch-all format. It basically means it can take any kind of data. It can be array, slice, struct, map, and it will print it in whatever way it is defined in the language runtime, right? It will take some default formatting style and it will print it. The %v. And similarly, if you use %+v, then it will annotate all the fields with the names, annotate all the fields of the struct in a key value style printing, right? As you can see here, we have the keys, we have the values, etc. We have the verb %q, which basically before printing wraps the value inside quotes. Okay. Similarly, we have %t with the t is capital, which takes a value and prints the type of it. So if you provide it some variable, it prints the type of that variable, which in this case is a map of key string and value integer. Let's say you want to customize how a certain type, let's say you have a type which is a custom type and it is of internally typed string and you have named it myString. Let's say you want to print this, but you want to follow your own formatting. When you pass this to a print function, let's say sprint or fprintf or println, any of the print functions, you want to follow a particular style to print this particular type. To do that, what you can do, you can define a method on this type, and the method name should be exactly this. The method name should be string, and the signature should also match. It should also return a string. And using this, you can format this in whatever style you want. So here what they are doing, they're taking this type, and before printing it, what they're adding a prefix called myString equals to %s to print a string, and they are taking the variable m and converting it to string and printing it. So using this construct, you can customize how a particular type. It can be a string, it can be an integer, it can be struct, any kind of custom struct, etc., etc. And you can customize how the print should look like for that type. Okay, now moving on, append we have already seen, initialization, constants. This part we have also explored, nothing to see here, nothing to see here. Variables, we already know how variables work. Init functions also we have explored, but we can take a look at this again, which basically says each file. Init is a file level function. So each source file can define its own init function to set up whatever state is required. So before anything runs in that file, the init function will be executed. So if you want to do some kind of operation, some kind of set operation, some kind of initialization statement or state setting operation, we can define that inside an init function. And that will be executed before anything else executes in that file. And init function is called after all the variable declarations in the package have evaluated their initialized and all the imported packages are initialized. So the way it works is we have, going back, if you want to take a look, let's say we open this file, and assuming this file has an init function, the way it will work is all the import statements will be evaluated first. So all these files will be evaluated in whatever hierarchical structure that Go follows. Then all the variable declaration at the top level will be evaluated. Then the init functions will be executed. Okay, that's the timeline it follows when a particular file in a Go program is getting evaluated. Same way, methods we have already covered. Pointers versus values, this we have already discussed, when to use value, when to use pointers. The previous video, interface and other types. Interfaces also we have pretty much covered. How to convert interfaces, that's also done. Interface conversions and type assertions, this part also we have pretty much covered. So nothing new in this here. So we already know how the blank identifier works, right? If you have some kind of function call, some kind of expression, and you want to omit some value, because if a variable is not used in a program after getting initialized, the Go compiler will throw an error and your program will break. It won't let you compile the program. And that's the reason we can use this blank identifier, this underscore, to say that we don't need this variable, so you can ignore it safely. Okay, that's what blank identifier is for. Here, import for side effect. Sometimes, let's say we want to import a package because that package has some kind of initialization operation. Let's say this package in its init operation does some kind of state setting, which is useful in our program lifecycle. But we don't really need this in this file, but we want the side effect of importing it. So in this scenario, we can also use the blank identifier after writing import, so that the compiler does not complain, does not throw an error that this package is imported, but it is not used. Same way, interface checks. This interface check, this also we have already covered. Embedding also we have already covered. If we have two interfaces, then we can construct a new interface by embedding them. So all the behaviors of these two interfaces will be available in the parent interface. Okay, same works for structs also. We can embed other structs inside a struct, and we can get access to all the fields and all the methods of that struct in the parent struct. This is also nothing new in embedding here. Concurrency, this principle that we had discussed in the earlier video, share by communicating. Then we have Go routines. Go routines we have already covered. Each program runs in the main Go routine, and all the Go routines that are spun from the main Go routine run concurrently with the main one. Okay, and when the main Go routine returns, all the other Go routines are abandoned. And channels, we have already discussed that channels are some kind of tunnels, so that we can send data from one point and receive data at another point. And the best part is we can do that across different Go routines. Moving on. Channels of channels. The error interface that we have already covered. Go provides this particular interface called the error interface. And whenever we want to indicate that a function is failing, so we should return this error interface. And from the parent, from the caller, we can check whether the value of this error is nil or not. And depending on that, we can move on with our happy path or whatever program execution flow that we are following. Panic also we have covered pretty much in extensive way. Recover also, I don't know, that's pretty much all there is to it. I think 90% of the stuff that are already there in the previous two videos, the tour of Go and the Go language specification. So this document effective Go does not really add too much when it comes to adding new concepts, because I have personally already read this document a lot of times. In the previous two videos, the tour of Go and the language specification, I have already included this material in an indirect way. So there is nothing new here to discuss, which we have not discussed already, but I definitely recommend going through this document once, reading it end to end, so that you can consolidate your understanding from the previous two videos and this video, which is just an outline of what all there is in the effective Go section. And yeah, move on to the next